This is my new 3D printer. I got it cheap on eBay. It was $80 for the printer, $120 for shipping. They saw me coming. The reason I got it so cheap is it was sold 4 parts not working. One of the easiest ways to get your hands on a 3D printer is to buy one in this not working condition. So if you've got a little bit of know-how, you can buy one of these, fix it, and have a good 3D printer, usually a really high quality 3D printer on the cheap. So in today's video, we're going to take a look at what I got. We're going to see if we can fix it, and if so, we're going to see what works. So if you're interested in that, stay tuned. We'll get started. I chose this one because Makerbot used to be a really good 3D printer manufacturer. These machines are made in the US. They're made in Brooklyn, which I think is pretty cool. Typically the parts on the Makerbots are really high quality. So my plan today, I'm going to take this apart. I want to get it down to the point where I've got all the electrics disconnected, and then I'm going to hook up a power supply from my other Makerbot, and we're going to see if the motherboard works, and we're going to see if the LCD works and if it responds to touch. If that works, then we're going to figure out what parts we need, and we're going to put it back together. But I'm going to bring you guys along for all of it. So let's see what's in the box, I guess, so to speak. So we've got a couple of extruder steppers, so they're the steppers with the linkage for filament. I don't know why I've got 2, but I've got 2 here. And then I've got another one connected. It's also Moon's. And then there's another one here in the carriage. What else is in here? I've got the 2 bronze bushings. These would run along the linear guide rail for the x-axis, which I think I've also got in here. Okay. What else? A fan card. Here's the heatsink, and then the rest of the carriage assembly is in pieces. It's not in the machine. But on this, I've got the wiring, I've got the other extruder, and then I've got this long gold wire here, which isn't hooked to anything, but it looks like it's got the thermocouple on the end. So I would guess somebody was having trouble with an extruder and pulled it apart. And it looks like I am missing the extruder assembly, so the nozzle and whatnot. So we'll have to find that, or maybe we'll have to get one of those. Now I'm going to take this out of here, disconnect it, and then we'll see if the build plate looks any good. But I'm going to bring you guys around so you can get a better look at what I'm doing. So this is the carriage. It rides on a pair of rails, and those rails are controlled by a stepper motor that's here. You can see it. This one controls this direction. There's one mounted in the machine back here that controls it in this direction. And then there's a stepper motor underneath the printer that controls up and down. To get these apart on a Makerbot, these are snapped into place. So you would pop them down, they would just snap into place. On other printers, you have to actually remove the carriage assembly. So if you were doing that on this machine, you would remove these screws in top here. So if I take these Allen head screws here out, then that whole top end will come off. And then I need to remove the fan. It's held on only with these 2 lower bolts. And that will give me the fan, the heat sink, and the cover. That'll all come off together. So those are the screws right there that hold the fan on, and they hold the heat sink. So that fan comes off. Looks like here are a couple of spacers. So that is the fan off. And now we've got the stepper free. I'm going to unplug it and get it out of the way. So to get the extruder off of this bar, it looks like it's held in with some set screws on the back. Once those come free, it should just pull off. Okay, and that will pull through. And then before we can get it off, this right here, this little brass nut, this actually holds the thermocouple. That's how the 3D printer knows what the temperature of the extruder is. That uses a really small wrench. I'll bet that's a 5mm. I'm gonna grab one. So before I do that, let's remove the thermistor. Hopefully that's the right word. The heating element. Let's remove the heating element. It's a tiny little 2mm Once that comes out, then it should be able to just slide that out. Yep. And then we can unscrew the thermocouple. It's a shame also that the ceramic insulator is broken on this because these are really nice, ceramic. But we'll put silicone in there. So that's everything here. I should be able to pull this now through and get this plate off. Sometimes when you're working in the shop at night like this, you'll get some weird noise outside. You get a little spooked out. It's the middle of December, it's snowing outside, there's nothing out there, but I heard this sort of howling, screaming sound, and I tell you, it made the hairs on the back of my neck stand up. The joys of talking to a camera in your workshop by yourself in the middle of the night. So you guys are here with me now, but while I'm recording this, I'm all by myself. Okay, so that's everything off of the carriage, so we're going to pull that out of the way. And what we'll probably do is rebuild this by itself and then put it back in. Everything looks okay to my eyes except for the melting on the underside here, but I'll bet we can clean that up. So I peeked under the table here, and there's actually the other extruder is just stuck under there. So I'm going to disconnect the Z-axis here, the Z-axis stepper, so we can move that up. I'm going to flip it over. I'll show you how to get that Z-axis out, because we'll take that stepper out, and then that should give me the ability to move this table. I guess bed. It should give me the opportunity to remove the bed. So here's the motherboard. This is one of those mighty boards, and they're notorious for failure if they're exposed to electric shock. But this is the stepper for the Z-axis, so I'm going to remove it. Actually, it looks like it might be held in place from above. Yeah, it is. So let's flip it back over. So I need to remove that assembly, and it looks like to get it out, I've got to take the back panel off. So I think these are 4mm. So let's pull this back panel off. It's just held in place with 4 screws in the corner, and then one here where you would retain the Bowden tubes. And they're all 4mm. It's been a while since I worked on a 3D printer. So that one's 4, but these are 5 apparently. So I'll admit, it's kind of fun. Exciting Christmas project, right? Alright, so that's 4 screws, 1 in the corner, and then each corner, and then 1 for the Bowden tube holder. Jeez. Put that aside. So this is the bracket that would support the filament spools, and it also carries the Z-axis, and these screws are loose, a couple of them. So I'm going to take these all out. They look like they're 2mm, and that will let this come off, and then we'll see what's under it. Because I unplugged that stepper motor, there's no harm in manually turning it. So let's turn this, raise the build plate up, see if I can get to these screws underneath. And the 4 screws that we're after are right here. These hold the stepper in. Oh, hey, look, extra goodies. There's 2 extruders down in there. So these 4 screws here hold that Z-axis stepper in, and they're 2.5mm. I'm going to back those out, and then once these are out, we should be able to back the screw out and remove that stepper motor. And then after that, hopefully we can just pivot the whole bed, the whole build plate outward and take it completely out of the machine. Oh, there we go. So there's 2 last screws now that I've got that stepper motor out. Right here, you probably can't see them from your angle. Hopefully that helps, but there are these screws here. They hold this base in place. I'm going to take those out, and then hopefully I can just remove this entire build plate in one assembly. Alright. That did work. Alright, and then those those wires run into the main harness, but I can disconnect it here at the stop switch. So I'm going to do that. So I want to disconnect the other stop switches, and I want to disconnect the stepper for the Y-axis. And that should be everything disconnected so that I can hook up a power supply and we can test the electronics. The reason I wanted to unhook the steppers and the stop switches is that if there's a fault in one of these, I don't want them interfering with the functionality of the main board or this front LCD panel. So by removing those, we take them out of the system, we eliminate them, and then if we put them back on and we have a fault, then we can rule it as one of these. So I've got to run into the house and grab my power supply. We'll plug it in and we'll see if this power's on. So the power supply I had for my Replicator II, it's not compatible. It's got exactly the same power supply, but the end is different. So this one has a male pinned end and that one a female. I can't put them together. So in lieu of that, I was able to find a power supply for this, but they wanted $217. So I said, screw that. So instead, just to test this and see if it's going to work, we're going to do something super sketchy. So I've got a Meanwell power supply here. It's the LRS 224. This is a 200 watt, 24 volt power supply. The original for the Makerbot would have been a 220 watt, so this is close, we're within 10%. But I did some measuring on the board. I think I figured out where I can connect leads to. So we're going to turn this on, connect some leads to the board, and see if it'll power on. I use the multimeter and I check connectivity, and the two pins on this side of the power connector both are labeled V-, and they connect to the ground. So V- goes to the ground circuit, and I think we can connect to it here on this grounding lug. There's actually several grounding test points on this board. So on this side of the connector, this is the 24 volt side, and it's 24 volts comes in on both pins. Those flow from the connector to the center pin on this switch. So when you operate this switch, 24 volts either goes to this one or to this one, depending on what position that switch is in. So I think I can connect my 24 volts to this center lug on this switch and my ground to the ground point here. And when I power on the power supply, that should power on this board. I'm going to use alligator clips for the 24 volt side so it stays out of the way and doesn't short. On the ground side, I did not have a connector that would actually contact that small test point. So I'm going to use a needle connected to my alligator. I don't want to make this connection after the power supply is on. I don't want to create a spark or otherwise short this thing out. So I'm going to hold this in place and then I'm going to turn the power supply on. Hopefully this powers up and the LCD works. So we want to see first it power up, we want to see the LCD turn on, and then hopefully the LCD displays something and we can move it so it'll accept input. So I'm going to connect this to ground and I'm just going to hold this in place while I do this. And I'm turning on the power supply now. Oh, we've got some lights here. Ooh, and we've got a light on the LCD. It actually read, so it reads Replicator 2X. Hopefully you can see that. Let's see if it accepts input. So it was griping there about the heater not being connected, and of course it's not connected. I don't know if you can see that, but it is also accepting input. So what that tells me is we have a working board. I will admit, I did not expect that. So I don't want to spend the money on a Makerbot power supply for this board, simply because it's so expensive. This power supply, this Meanwell 200 watt, these are like 25 bucks on eBay. It just doesn't make sense to spend 10 times as much. So what I'm going to do is I'm going to find a way to wire this board so that it can be connected to this power supply. And now is probably the best time when we've got it apart. So we'll figure that out. I'll kind of show you what I'm going to do. So what you're looking at here, this is the power connector. It comes in and it's got 4 pins, and those 4 pins are here, 1, 2, 3, 4. And what happens is these 2 are marked minus, these 2 are marked plus, and I checked with a meter, there is continuity between these 2 and these 2. So internally on the power plug, these 2 are connected. So what I want to do is I want to connect wires to those set of pins there that'll allow me then to connect to a internal style power supply. So I'm going to keep this really simple. I've tinned a couple pieces of wire here. I'm going to set those over top of these pins, and I'm going to solder them to the bottom of the solder joints. So that'll give me two that look kind of like so. And these two then can connect to my 24 volt power supply. There are two tiny resistors right here, 1 and 2. I've got to be really careful with those. If I damage them, I don't have the soldering ability to repair those. I don't have any thermal pads, so I'm just going to stick some electrical tape over here just so solder doesn't get dropped or something stupid. So that's what I'm going to do. I've got the soldering iron heating up, and I'm going to start with the negative side. I'm going to solder it, and then I'll solder the positive side. I'm going to put a little bit of flux on these. I don't want to get that too close or I'll melt it. All right. All right. All right, done and done. So that's the end result. I'm going to put a little liquid insulator on this just to help prevent with the possibility of any short. Try and do this neatly. All right, let that dry. And I suppose I should double check connectivity. So these should be continuous. And they are. Now the black wire and the red wire should not be. I'm using 16 gauge wire here. It's rated for 10 amps at 24 volts, so it should work out all right. Let's check continuity on these two, make sure there's not a short. All right, I don't have any. And now last, I want to check with the pins inside the connector and make sure that those pins and these wires do have connectivity. All right, so first, the negative side. Yep, and now the positive. Yep, we're good. All right. I added a little heat shrink and a label so that when I come back in here the next time, I remember what I did. I've very temporarily wired the board up to the power supply I'm going to use. This is a Meanwell LRS 224. It's a 24 volt power supply, 200 watts, makes about 8.8 amps. The Makerbot power supply, it's also made by Meanwell, but it's a 220 or a 9.2 amp. This was as close as I could get. I didn't want to exceed 9.2. So we're wired up temporarily. I haven't turned on the power to the power supply, but let's turn on the power supply. Let's check, see if everything works. Hopefully I didn't let the smoke out of this thing. Watch the LCD. Hopefully you can see it when it powers on. And we want to make sure we've got lights here, LCD powers on, and the control module here accepts input. So power on. All right, got a power LED. Now Makerbot on. Got LEDs here. We've got an LED here. It's gonna give us an error because nothing's connected. Yep, so I'll hit OK. Sweet, so I would say that is working as expected. We can still use the Makerbot's power switch and just leave the power supply on full time if so desired. And I've printed a little plug that fits into the original 24 volt socket. This is still live, so if you put a voltmeter across here, you would get 24 volts. So I want to keep things out of there, but I also want to just have this look clean, and I want to make sure that nothing ever gets put in there, nothing ever gets plugged in. I don't know why it would, but you never know. So that plug fits in there, fits nice and tight, and that will just keep things out of that connector. This power supply I'm using, it's got 4 holes right on the top here. Those are 150 millimeters apart in this direction and 50 in this. I laid that out with a pair of calipers and I've drilled mounting holes. And what I'm going to do is I'm going to mount this to the underside and then I'll install screws from above. I wanted to keep some space between the power supply and the actual body of the printer just to allow airflow. So I printed off some spacers of the appropriate length. The holes on this power supply, they're M4 by 0.7. So if you happen to be using the same one, that's the screws you'll need. If you were to mount this directly to the body, these would be 6 millimeters long. I'm using 10 millimeters so I can have the extra space for clearance. All right, that's attached. So here's how that power supply came out when it's fully mounted. You can see I made a fan bracket here to add a fan, just for some additional cooling. I don't know how hot that's gonna get, but I thought it was a good idea. I routed the wires, you can see them here. These are the ones that run into the backside of the motherboard. And then there's a main connector right here. So they run around, they connect up to the V plus and V minus on the power supply. And then this is that switch holder I printed. And you can see the wires come out of it and they run into the input of the power supply. Now if you do this, keep safety in mind. The fumes coming off the plastic are most likely toxic. You have the potential to start a fire. Pretty much most dangerous way you can do this. So don't follow what I'm doing here, but if you do, be safe. I pulled the carriage assembly apart. Some things I found. The big one is that this plastic is broken. So where the stepper motor mounts is broken off. I didn't do that. And the second is that when I pulled this apart, the limit switch or the in-stop limit switch came off. So it looks like it broke right at its joints. It was bent upward pretty good. I think this took a hit maybe when this thing was being shipped. So I'm going to replace this plastic piece and I'm going to also replace the limit switch. I did find these limit switches online. I've used them before, they're alright quality. The downside here is that the connectors are not the same. And I would really like to use the original wiring and hardware for the Makerbot. So I think what I'm going to do for the limit switch is I'm going to desolder this connector and I'm going to transfer this one over. And that will let me use the Makerbot's wiring and then one of these cheaper, easier to get switches. I checked them with my multimeter and they are the same pins, the same orientation as the original switch. So these should be perfect. It actually says right there, designed by Makerbot.com. So I'm pretty sure this is just a knockoff. So for the plastic piece, FlashForge does make and will sell you spare parts. I was actually able to get all three plastic parts, so that's both sides of the XY and the carriage. And those were right at 30 bucks. So this one is a near identical copy of the Makerbot part, so it should work out. The only real difference is the missing Makerbot logo. This is the other side piece of plastic, and on this one, Makerbot kind of had a design flaw. So this is the idler pulley for the Y-axis, so this is what supports the belt. And they just put a plastic gear over top of a stainless steel axle and push that into plastic. But over time that wears, and you get to the point where this binds in there and it won't spin. And what happens is that axle then starts to spin and it chews up this plastic and wears in. That's one of the places where the aftermarket copy is better. So what FlashForge did is they opened that up, and this now accommodates a bearing. So you can install an 8mm bearing in here to carry this idler gear and axle, and it completely eliminates the problem. So because of that, I'm also going to use the other side piece for the carriage. To lubricate these bearings, these bronze bearings, I actually use it on the linear bearings too. I use automatic transmission fluid like you'd use in your car. This is one of those topics that everybody's got an opinion on, and it doesn't matter what my opinion is, it's going to be wrong. But you want a light oil, something that will stay in the bearing or on the rod, protect it from rust, and provide just a nice film of oil for it to ride on. Things like engine oils are too thick, they're too heavy, and greases are way too thick. So this is a nice, light, cheap, readily available oil, and it does a really good job. And this is that limit switch you just saw me solder. On the Makerbot, it was held in with a screw. The FlashForge extrusion does not have that, and it doesn't fit in there tight enough to secure that. So I'm going to probably mark that and then put a screw in just like Makerbot did. I've got one that's in really good shape. That's for the left filament. But the other, the right side, that one is not. You can see it's broken off and will no longer hold the tube. I got some of these, I guess we'll call them Bowden tube terminals, holders maybe. But what I want to do is see if I can find a way to bond these into that opening and use these as a retaining mechanism instead of just trying to get the Bowden tubes to fit down in these holes here and held in with friction. So I'm going to cut the end of this off, cut it flat, and then I'm going to see if I can make this work. Yeah, so I'm going to heat this up so it's warm and it kind of melts this plastic, and I'm going to run it in and try and get it all the way seated. Okay. And thread it on in. Yeah, that tightens down really nicely. There you go, we've got two of them, they match. And they give me something for the Bowden tube to fit into that'll hold it in place. And also a nice way to guide the filament in. We'll just check, make sure it works. Yep, that feels really nice. So those are the two filament drive steppers. They look good. Alright, so we're going to start with the hot end. This one's coated in RTV silicone. I did this because while silicone socks are available, I couldn't find one. They're all sold out. This is actually really easy to apply and it works well. It just doesn't look very nice. So the first thing we're going to install is the nozzle. And the nozzle threads in on the side that contains the set screw for the heater. Alright, and then once we have that in, the next thing to do is install the filament tubes. And you want to tighten these down until they seat on that nozzle. And once that's done, then we're going to install the heater. And we want that heating element to stick out with the wires coming out the back. We want as much heat into this heater block as we can get. So I like to coat the heater with some thermal compound. So this is like you'd use on a heat sink for a computer. And little of this stuff goes a long way. And the heater then just slides in. And then this heater is held in place with a set screw. And I don't have both set screws, so I'm just going to use a short 3mm socket cap screw. You just snug that up. And then the last thing to put in this is the thermocouple. Alright, so here's how the carriage goes together. We start with this insulator, and this goes on such that these set screws go towards the back. And that's held in place through these two screws on the bottom of the carriage. Okay, so these are the hot end assemblies I showed you. And the way these go in, the thermocouple goes in first. And that just pushes in place. It is held in place with this set screw on the back side of the insulator. Push the thermocouple wire down in to that channel. And take your extruder stepper, fit that. You want heat to flow from this insulator into the heat sink. That's how it gets rid of the heat. So I've put a little bit of thermal paste on here, and that will just help with conductivity. With your fan shroud, and you've got the two long bolts, and then you've got the fan, and we want the fan to go in so that the wiring is towards the center. So it's those two bolts into the fan. And then there's two spacers, and those take up the gap between the fan and the heatsink. And then after that, the heatsink goes on. And then this whole thing is inserted through these holes in the insulator. And then when they tighten down, they pull the stepper up. All right, there's one side. I'm going to clean up this excess thermal paste. And now we're going to do exactly the same thing with the other. Let's try this again. So I brought the Makerbot Replicator into the house. I've got it set up next to my other machine. We've got to do some tests before we can actually use it. I haven't powered it on. I don't know how it's going to work, but you guys are here. You might as well watch. So I'm going to bring you in so you can see a little better, but we've got a couple things we need to do before we can print with it. The first, I want to turn it on and I want to tell it to home axes. That way we can see that all the stepper motors work, that there's no weird skipping, and we can check and make sure that the end stop switches are working. The second thing I'll do is I'll preheat it. So what that'll tell us is if the heated bed works, it'll tell us if the extruders are getting hot, if they're going to temperature. It'll let us know the thermocouples work, and we can test the fans. So if we get through both of those, then I've got some parts I want to print, so we'll draw something up in SolidWorks, and we'll put some filament in this and we'll give it a shot. So I'm going to bring you guys in, and let's see what happens when I turn it on and I tell it to home axes. Alright, I just turned on the power supply. Oh, it looks like the switch was already on. Well, that's a good sign. The display is a little hard to read. Alright, so I am going to go in, and first thing I'm going to do is I'm going to tell it to home the axes. So that'll take it to its home position. And that seems to work. Alright. I'm going to move the Z-axis downward a little bit while we heat it up. That way if anything comes out, it doesn't melt the bed sticker. Alright. And tell it to preheat. Preheat both extruders and the platform. Let's just check it all. So something I did not know was when this heats up, It heats up the bed first, and then it heats up the two extruders. So it doesn't do the extruders in the bed at the same time. What it's saying right now is we're at 52 degrees of 110, and that's in degrees Celsius. So we're about halfway there. It feels warm to the touch. So I'm gonna let this keep running, see if it gets up to 110, and then we'll see what it does with the extruder. Oh, hey, we're there, we're up to temperature. So I think that works. I'm pretty happy with that. It wasn't that much work actually just to get this thing up and running, other than taking it apart and replacing some parts, printing some stuff. So now that it's here, now that it's running and it heats up and it looks like everything's moving the way it should, I want to print some of these clips that hold the Bowden tubes in place. So I've got something similar on my other Makerbot, but these will look like a wishbone, and what they'll do is they'll hold the tubes up along with the wiring. Look at how good that turned out for its first print. Like, I am blown away. Alright guys, that's it for today's video. The Makerbot is working really well. I've uploaded all the 3D printed parts that you've seen me use to Thingiverse. I'll put a link in the description. That includes the plug for the socket, the spacers to hold the power supply in place, and the adapter for the power supply switch. I hope you enjoyed watching today's video. I had a lot of fun making it. If you did, please consider subscribing. So with that, thanks for watching.